Welcome everyone to Unit 3, Quadratic Functions. Lesson 1 is going to focus on graphing quadratic functions. You've seen these before in Algebra 1 and maybe even a little bit in geometry, but we're going to really look at these things in detail. There's a lot of little pieces that we can work with that will really help out with a lot of different situations. So, let's take a look at them graphically. A quadratic function is in the form of ax squared plus bx plus c, where our a value is not 0, right? We have a square variable here. That's what makes it a quadratic. We have a few pieces of parabolas that are pretty important that we can get from the equation itself, as long as it's in standard form. This is in standard form here, right? It's in descending order of power on our variable. So let's take a look at some of those components. You might want to write these down, so if you want to pause the video, go for it. The axis of symmetry. It's a line through the graph that divides the parabola into two congruent halves. Okay, picture right here, you see our parabola and our axis of symmetry. It's this dotted line that runs right through it. Okay, it's going right through that point right here, which we'll get to in a moment. But what's nice is that it's dividing this parabola in half, congruent halves in fact, so that means the distance from here to here, this center line, is going to be equal on the other side. That's going to be pretty useful because we'll be able to get points based off of the Y-intercept, and we'll be able to get another point for free just because of that axis of symmetry. And it has its own equation. Okay? The equation for the axis of symmetry is going to be x equals negative b over 2a. I hesitate to say negative b because I want you to be thinking about the opposite value of b, and we're going to make sure to assign that to b itself. Okay, and we're going to do a couple of examples so you'll see exactly how these things work. Next we have the Y-intercept. Really cool. The Y-intercept is whatever that c value is. Okay? If you think about it, if we were to plug in 0, which would be where the y-axis lies, at x equals 0, everything would eliminate that's attached to x. The only thing that would be left would be that c value. So we got a pretty easy one just from looking at the equation itself. Then we have the vertex. I mentioned we would talk about this in the back up here, right? So here's the vertex now, the point where the axis of symmetry intersects the parabola. Okay, here it is. That's the vertex. That point right there. That's that axis of symmetry that we were talking about. And I also pointed out the y-intercept. Okay, very important, which is why there's a few stars around this too. The formula to find the vertex. Notice how we have the same equation because that axis of symmetry runs through the vertex. So it makes sense that these would be the same point. But then we want to know whatever height is associated with that, so we have to plug in that function. We have to evaluate and then figure out what the height would be. Okay? That's where your vertex comes from. And finally, we have minimum or maximum. It would be the smallest or the largest value in a quadratic function. The y-coordinate of your vertex is the min-max value, and depending on which way your parabola opens, you'll have either a minimum or a maximum. If your a value is positive, you'll have a minimum, right? That means that your parabola opens up in the classic U shape, making the lowest point a minimum. Everything else would be greater than that. If your a value is negative, you'll have a maximum, right? Because your parabola will then flip upside down, making this the highest point. Everything else would have to be lower. Okay, so we've gone over all of the really important vocabulary terms that we need. Hopefully you have these as a reference, because when I change this page, you're not going to see those formulas anymore. Alright. Now, we're going to go into a problem in just a moment. I just want to give you an idea of what these can be used for. The graphs themselves are pretty useful in anything that has to do with physics, which would include, you know, like fireworks being launched into the air, or maybe a diver jumping from someplace. There's all sorts of applications we can use for this, so we want to be able to figure out any piece of this quadratic when asked for it. Okay, so let's try out a problem. Here we have our quadratic function, negative 2x squared minus 12x minus 9. We're going to start off first by finding the axis of symmetry. Okay, axis of symmetry. It tells us it's x equals. I'm assigning the negative sign to the top, and I want to take whatever b happens to be in the equation, including the sign here. So it would be negative 12 over 2 times our a value, which is negative 2. Remember, we want to include whatever that sign happens to be. Alright, so that gives us x equals 12 over negative 4, which is negative 3. So we just found the axis of symmetry. That was our AOS. Okay, one of the things they asked us for. What that means is at negative 3 here, we have a vertical line that we're going to put in dashed. In fact, I'm going to do it in a different color. You guys can do it just dashed with your pencils or pens, just so that we can see it here. Okay, this is our AOS, axis of symmetry. Now, if you remember, our vertex is going to fall somewhere on this line. So what we need to do is figure out what that height happens to be, which would mean evaluate in this function. So here we go. It's going to be the vertex. We're evaluating negative 3. Alright, so let's see, that gives us negative 2 times 9. That would be plus 36 minus 9. Negative 18 plus 27. And that gives us 9. So we come up with f of negative 3 equaling 9. That means, remember this is our y coordinate, that our vertex is going to fall at negative 3, 9. So here we go. Here's 5, 6, 7, 8, 9. So here is our vertex. Now we can get a couple of other things too, right? One of the easiest ones is the Y-Intercept. We could have done that right off at the beginning, but I wanted to wait until now because now we have a couple of other points to work with, right? We have the Y-Intercept and we have our vertex here. All I have to do is just plot whatever that number is on the y-axis. So that's down here. Another cool thing, because our axis of symmetry tells us it's equal on both sides of this line, all I have to do is count from the y-axis to the axis of symmetry. Here it's 3 units, and if I just move horizontally 3 units on the other side of that line, I know I'm going to get a point. Alright, and we already knew that this was going to be open and down because our a value is negative, and we can see it here. Alright, all we have to do is go right through. Alright, last thing is they ask us what the minimum or maximum value happens to be. Now, it's whatever your y-coordinate is for your vertex, but we need to make sure that we list if it's a minimum or a maximum. Because it's the highest up that we can go, that would be a max. So we would want to say max of 9. Okay, so we've got all of the things they asked us for, plus we graphed it. Not very difficult, right? All the work that we needed to do, we could fit right off to the side here. I think you guys should be able to handle these pretty well. We're going to do one more example together, and then you'll have one to try out on your own. Alright. Start off with the axis of symmetry. Remember, it's x equals opposite or negative B value here, it's 6, divided by 2 times A, which here is 3. We get negative 6 over 6, giving us our axis of symmetry at x equals negative 1. So let's plot that real quick. Again, I'm going to do that in a different color. Alright. Somewhere along that line will be our vertex. Let's find out that value. We'll evaluate at negative 1. Okay, 3 times 1 minus 6 plus 4. 3 minus 2 is 1. So we found our vertex at 1, positive 1. Here it is. That's our vertex. We can find a y-intercept pretty quick. It's whatever our c value is. So positive 4. I know I have 1 unit space between the axis of symmetry and that y-intercept. So if I go 1 on the other side, I see that it matches my positive a value. Just drawing the rest of that graph. And we just have to decide, is this a min or a max? Well, it's the lowest it can be, right? Our a value is positive, so that gives us a minimum. Minimum of 1. I'm not going to get any smaller than 1 on that particular problem. So I have one more of these for you to try out. Okay, here it is. If you'd like to pause the video and try it out, and then we'll go over it right after. Let's check out how you did here. Let's start again with the axis of symmetry, how we always have started. We want to do the opposite of B, all over 2 times A. Gives us positive 16 over negative 16, giving us a y-intercept. I'm sorry, not y-intercept, and an axis of symmetry at 1, negative 1. Oof. Alright, let's see. Here's our axis of symmetry. If we evaluate negative 1, I'm coming up with a vertex coordinate negative 1, 9. We're way up here. We have a negative, so we know that it's going to open down, so we'll definitely show up on our graph, and that tells us that it's a maximum value of 9. So we got that all taken care of. And the last piece would be this y-intercept right here at positive 1, and I have a reflected point on the other side at positive 1, and here we go, right straight through. That should have probably went a little bit further out. Sorry, squiggled back in. There you go. Check out your answers compared to these. See how you did. Pretty easy stuff, and if you keep all these in mind when we start getting deeper and deeper into this unit, we're going to be doing some applications later on, but you'll find that a lot of this stuff is pretty straightforward. We're going to look into finding out where the parabola crosses this x-axis in the next few lessons. That's something pretty important, and I'm going to use a lot. So see you there at video 2.